This microcredential deals with ignition systems and consists of 5 targeted skills. This targeted skill deals with ignition system basics. Something is required to ignite an air-fuel mixture inside the cylinder of an engine. A collection of parts makes up an ignition system. The ignition system has 2 purposes. The first is to make or create electricity that becomes a spark. When the electricity jumps across the gap at the tip of the spark plug, it ignites the air-fuel mixture in the cylinder. The spark lights the fire in the cylinder. The resulting explosion pushes the piston, thus creating power. Now, how many volts are needed to create that spark? At least 10,000 volts. But why so much? A typical spark plug gap is 30 thousandths of an inch. While that doesn't sound like much, air is not a conductor of electricity. Enough voltage needs to be generated to jump across the gap quickly and easily, and the spark needs to be open and exposed to the air-fuel mixture. Also, the spark must be a high-energy source to ignite the air-fuel mixture instantly. Inside the engine, the spark needs to jump thousands of times in a minute to keep the engine producing power. The second purpose for the ignition system is to make the spark occur at precisely the right instant during the cycle, that is, timing the spark. If the engine is running at 2,000 revolutions per minute, the spark needs to occur at 1,000 times per minute. If that spark could be seen, it would look like a steady stream of electricity, but it is not. The spark occurs at the right moment and then is taken away. Now, how long does it take for the spark to jump across the gap? Just a fraction of a second, but it does take time for that to happen. How long does it take for the air-fuel mixture to ignite and burn? Just a fraction of a second, but it does take time for that to happen. How long does it take for the resulting explosion to reach maximum force? Just a fraction of a second, but it does take time for that to happen. Because of the brief time that it takes for those events to happen, the electricity needs to be sent to the spark plug at precisely the right instant. When the piston is at its peak in the cylinder, that location is called TDC for top dead center. When the piston is as low as it can go in the cylinder, that location is called BDC for bottom dead center. By adding 2 adverbs before or after, piston location can be further described. When the piston reaches TDC and starts down, that location is called ATDC for after top dead center. When the piston is moving downward but has not reached BDC, that spot is called BBDC for before bottom dead center. Now, when the piston has passed through BDC and is headed upward, that position is called ABDC for after bottom dead center. When the piston is moving upward but has not reached TDC yet, its position is described as BTDC before top dead center. Now let's review these abbreviations and their piston positions. TDC is top dead center. ATDC after top dead center. BBDC is before bottom dead center. BDC is bottom dead center. ABDC after bottom dead center. And then BTDC is before top dead center. The crankshaft revolves in a circular motion with 360 degrees in that circle. By adding degrees to those term locators, the piston location can be located precisely. Now, when should the spark be sent to the plug? If it is sent when the piston is at top dead center, remember that it takes time for events to happen. The piston will have already passed top dead center and started downward. Now if the piston is moving downward, by the time the explosion has reached its peak, a good push will not occur. The best time for the spark to be sent to the plug is early, BTDC, before top dead center. This way, by the time things have happened, the piston has moved to TDC, which is top dead center, providing a better push from the explosion. The common time is 20 degrees before top dead center. Engineers will use various times for different engines and different applications. Now remember that the two purposes for the ignition system are first, to make the spark, and second, to time that spark during the cycle. Next, there are two types of ignition systems. The first one is the magneto type. On all handheld equipment, a small, lightweight, portable, and reliable ignition system is needed. A magneto type system will work nicely for this application. Only a few small parts will generate the 10,000 plus volts needed at the spark plug. A magneto uses a magnetic reaction to move electrons through a wire that becomes the voltage at the spark plug. The second type of ignition system is the battery type. Inside a battery, there are lead plates and sulfuric acid. The acid reacts with the lead plates, releasing electrons. When those electrons move through a wire, they become the voltage needed at the spark plug. Weight is not as much of a concern with larger engines, like riding lawnmowers or zero-turn tractors. Now let's recap. The two purposes for the ignition system, whether a magneto or battery type system, are to make the spark and to time that spark for optimum power to the engine.